Today, we are solving the very first algebra problem in International Mathematical Olympiad. This is problem 2. The problem states that for what real values of x is square root of quantity, x plus square root of 2x minus 1 plus square root of quantity, x minus square root of 2x minus 1 equals a, given a equals square root of 2, a equals 1, a equals 2, where only non-negative real numbers are admitted for square roots. It is an easy question compared to today's problems, as this type of problems can be solved by high school students. Let's find the solution. Since the square root of 2x minus 1 exists only when 2x minus 1 is greater than or equal to 0, we find that x is greater than or equal to 1 over 2. Next, we square both sides of the equation. Expanding the left side gives x plus square root of 2x minus 1, then twice the product of two terms, and x minus square root of 2x minus 1, which equals a squared. These two square roots cancel each other. We notice that these two expressions have the same terms with different signs. So we multiply these two expressions to get x squared minus 2x minus 1. Simplifying inside the square root gives 2x plus 2 times square root of x minus 1 squared equals a squared. Square root of x minus 1 squared equal absolute value of x minus 1. Here we need to consider two cases based on the value of x. When x is less than or equal to 1, we have 2x plus 2 times 1 minus x equals a squared. Simplifying the equation gives us a squared equals 2, and thus a equals square root of 2, which is the value we want. So when x is less than or equal to 1, a is square root of 2. But notice that x must be greater than or equal to 1 over 2. The solution for this case is x is in the interval between 1 over 2 and 1. Now let's consider when x is greater than 1. Then we get 2x plus 2 times x minus 1 equals a squared. Then we can rearrange the equation to get x equals a squared plus 2 over 4. For a equals 1, x equals 3 over 4. But this is not valid because x must be greater than 1. Therefore, there is no solution. Now we want a equals 2, then x equals 3 over 2. This is greater than 1, so it is a valid solution. The final solution is, for a equals root 2, x is between 1 over 2 and 1. For a equals 1, there is no valid solution, and for a equals 2, x is 3 over 2.